We now determine the parametric equations of the line which passes through this point negative 4, negative 4, negative 2 and is parallel to this vector negative 7i plus 7j, negative 7k. So here we can utilize this formula, that is if a line passes through the point x1, y1, z1 with the direction vector a comma b comma c, then the parametric equations of the line is given by x equals x1 plus at, y equals y1 plus pt, and z equals z1 plus ct. So let's identify the point as well as the direction vector. Since the line is parallel to this vector, we consider this vector as a direction vector. So this is a direction vector. I write down this in component form. So it is negative 7, 7 and negative 7. This is a direction vector. And this means A is negative 7 and B is positive 7 and C is negative 7. Now let me put the point. That is, we have the point negative 4, negative 4 and negative 2. So let's use this formula, that is x equals, this is the point, we can write down this as x1, y1 and z1. So therefore the parametric equations of the line is given by x equals x1 plus at, and this implies we can substitute the value of x1, which is negative 4 plus a is negative 7. So it is negative 7. This will become negative 7 times of t. So it is x equals negative 4, negative 70. Now let's write down for y. So we have y equals y1 plus bt. And this implies y1 is, we write down y equals negative 4 and b is positive 7. So it becomes plus 70. And finally for z, so z equals z1 plus ct, and this implies z equal to, let's substitute z1, which is negative 2, and ct plus ct, c is negative 7, so negative 70. So these are the parametric equations of the line, and this means choice 3 is correct. Let's do question 15. So here we are given 2 points and we have to determine the parametric equations of the line. So to determine the parametric equations of the line, we need a point and a direction vector. Here we are given only 2 points but not a direction vector. So first we will find a direction vector, that is PQ vector will be the vector uh, uh, which will be the direction vector. So let's find the PQ vector. That is, by doing the subtraction, we start from this point Q. We do like this, that is negative 6, negative of negative 1. We do the corresponding subtraction, and then I take this y, 5 minus of this negative 1. Then I take this z, that is negative 7, negative of negative 3. So we do the subtraction to get this PQ vector, and this vector we can consider as V vector or the direction vector. This is negative 6, positive 1, and this is 5 plus 1. This is negative 7 plus 3. Let's simplify this. So therefore V vector, this equals negative 6 plus 1 is negative 5. 5 plus 1 is 6. Negative 7 plus 3 is negative 4. So we have got this direction vector. We can denote this by A, B, and C. So this is A, that is A equals negative 5, B equals 6, and C equals negative 4. And we can consider any one of the point. I consider the point P, that is negative 1, negative 1, and negative 3. This is x1, y1, and z1. So we have the point as well as the direction vector. We can write the parametric equations of the line. That is x equals x1 plus 80, and this implies x equals, we substitute x1 which is -1 plus 80, a is -5. So I write down this as -5t. And another parametric equation is y equals y1 plus bt. So this implies y equals, I substitute y1 which is -1 plus b is 6, so it is plus 60. And z equals z1 plus ct. So this implies z equals, substitute the value of z1 which is -3, c is -4, so therefore this becomes -40. So these are the parametric equations of the line passing through the two given points, and this means choice 2 is correct. Let's do question 16. So here we are given the point as well as the line is perpendicular to this plane. So let's do some diagram. Let's consider this as the plane, as the given plane, and there is a point P. So I'm going to draw the normal to this plane. So this will be the normal to the plane. And since the line is perpendicular to the plane, you can draw it like this, and it is passing through this point. So this is perpendicular as well as, let's say this is normal vector. And so now we can diagonally see that this normal is parallel to this line. And this means we can consider the normal vector as the direction vector for the point. So first, let's identify the normal vector. We take only the coefficients of x, y, and z, which will be the components of the normal vector. So therefore, I write down normal vector. This equals -4. I'm writing in component form. So +4 and then 7. And so this is our direction vector. So this direction vector, that is -4, 4, and +7. So this is A, B, and C. A equals -4, B equals +4, and C equals 7. And we also have one point, that is point P is -7, -4, and +3. So now we can use this parametric equations of the line. That is x equals point P. We can write down this as x1, y1, and z1. So x equals x1 plus 80. That is, I substitute x1, which is -7. A is -4, so it becomes -4t. And then y equals x2, y1, which is -4, plus bt. B is +4, so it becomes -4 plus 4t. And z is z1, so z1 is +3, 3 plus ct, that is c is 7, so it is 70. So this is the parametric equations of the line given the point and perpendicular to the plane. And so choice 3 is correct.